Besides the reaction with bromine, alkenes can also react with water in the presence of an acid to form an alcohol. And this type of reaction is called hydration. And here it is important that we use a strong acid, and a strong acid can, for example, be aqueous sulfuric acid. And then if we have this acid and water, then we always write it in this way. So we write a water molecule and a proton to clarify that we have diluted acid. And then you can see that we have a protonation of the carbon double bond in order to form a carbocation. And this is here the first step. So we start with our alkene, and then we have this hydronium ion from the diluted acid in the solution. And here we will see the protonation of the carbon-carbon double bond, and we end up with a stable carbocation. And here it is important that the Markovnikov rule is valid, so we will always form the more stable carbocation, in this case the tertiary carbocation. And then in the second step, the nucleophile reacts with the carbocation, and here it is important that we see that the nucleophile can either be the water or the conjugated base of the acid. And which nucleophile now reacts is dependent on the concentration. And in our case, we have a diluted acid. That means water will react as nucleophile, and this is indicated here. So then we have the fast nucleophilic attack, and then in the third step, we have the deprotonation step, which is also fast, and here water reacts with the oxonium ion to form an alcohol, and then also to regenerate the hydronium ion, which acts as catalyst in this reaction. And why does this hydronium ion now react as catalyst? You can see it here. We get it out, and it was given in. So a catalyst is never consumed during a reaction and always recovered after a reaction. And what is also important is that we see that all steps are now reversible. So in principle, you could also convert the alcohol back to the alkene in a dehydration reaction. And the formation of the alcohol is therefore regioselective. More general, we can always say that the hydration of an unsymmetrical alkene is regioselective, and here the Markovnikov rule is valid, which says that the OH group will always be at the more substituted carbon atom. If we now have, as example, this 2-methyl-prop-1-ene, which is an unsymmetrical alkene, we convert it in acid solution with water. We will see that in principle two products, the 2-methyl-propane 2-ol and the 2-methyl-propane 1-ol, and we can see here the OH group higher substituted carbon atom, whereas here the OH group would be at the low substituted carbon. And this product is selectively formed as Markovnikov product, whereas this product is not formed, and it is called the anti-Markovnikov product. So now you might wonder, is it then possible to form a primary alcohol? And I can already say yes, it is. And therefore we just have to go another way, which will be explained in the following slides. We will have an addition of borane instead of hydration of the alkene.